Hi, we at Oriole Electronics thank you for taking the time out to go through this presentation. Over the course of this video, I will be giving you a brief overview of the liquid crystal module technology. It will include the difference and the descriptions between the different kinds of LCMs, that's alphanumeric, graphical, and the segment or numeric, or what we often refer as customized displays, the breakdown of an LCD, what it really consists of, and also some technical characteristics and points of the LCD. Now we'll begin with the alphanumeric LCD. The alphanumeric LCD is basically defined by the number of characters per line and the number of lines. So as an example, the display on the screen which you can see is an 8 by 2 display. It has 8 characters per line and it has 2 lines. This display, for example, is a 40 by 4 display. So it has 40 characters per line and 4 lines. Now I'll also give you an example of a 16 by 2 display. All these three displays displayed are 16 by 2, but they're all of different sizes. So even though they are alphanumeric, they are 16 by 2 displays, they're all different sizes. Also have a look at the kind of characters an alphanumeric display can display. You can have alphabets, you can have numbers, and plus there are certain special characters that can be displayed in an alphanumeric LCD. Now typically what happens is that the IC which is used can support two character sets. So typically what we use is the English character set and the Japanese or Kansas character set. But apart from this, you also have the option of Russian or European or Cyrillic font. Now, in this case, if you want to use the alternate options, you need to place like a separate order and we need to make that customized, because generally what we do is English and Kansas characters as standard. So now you'll just see some of the examples of standard alphanumeric LCDs. The standard sizes are 8 by 1, that's 8 characters, 1 line, 8 character, 2 line, 16 character, 1 line, 16 by 2, 16 by 4, 20 by 2, 20 by 4, and the largest going up to 40 by 4. Now we also have certain customized LCDs, but purely alphanumeric. So for example, this 20 by 3 LCD that you see on your screen, it's completely alphanumeric, so there are no other special characters. But the first line is of a smaller text, the font is smaller in size, and the second and third line are of a larger size. So this sort of just covers the entire gamut of alphanumeric LCDs. Next, we'll be going on to graphical LCDs. So graphical LCDs, as the name suggests, are displays where you can basically display whatever you like. You can make text, you can make graphics, you can have fonts which normally aren't a part of the standard alphanumeric character set. So for example, if you have like the Devanagari script or regional languages, Indian regional languages, all of these can be displayed in the graphics LCD. Now a graphics LCD is defined by the number of dots. So the horizontal dots and vertical dots. So for example, if you have a 128 by 64 graphics display, it means that horizontally there are 128 dots and vertically there are 64. So you have these 128 by 64 dots to display whatever you like on a changeable basis. So one screen you can show some graphs, one screen you can show text or whatever you need. Again, like I said, each image or each whether it's a text, even a text is taken as an image. So if you have a drawing or you have a alphabet, whatever you want to display is taken as an image. A bitmap is made of that image and then it is displayed. The standard graphics LCDs are 128 by 64, 240 by 128, 240 by 64 and 320 by 240. The details of all these LCDs, alphanumeric and graphical, the standard models, are available on our website. You will get the number of dots as well as the dimensions of the displays. Now, again, as in the case of alphanumeric LCDs, the graphic LCDs come in different backlight colors and in different colors of panels. And these characteristics will come later on in the presentation when we go into the details of the technical characteristics of the display. So now finally we come to the third kind of LCMs. These are numeric or customized or segment type displays. They are typically customized displays not meant for generic applications but meant for a specific application, a specific product. So, for example, you have calculator displays, washing machine, any product which is going to be made in large volumes. Typically, cost is a factor, and the customer also wants a mix of alphanumeric and some special symbols. So as an example, you can see on this display, we have 7 segment characters and we also have 14 segment characters. So you can have a mix of both. You can also have special characters. You can also have symbols like percentage or degree Celsius, degree Fahrenheit, battery symbols, etc. These displays are typically used only with the glass panel. So it's not necessarily used as a complete module, but you have cost savings when you use only the panel, and the microcontroller is, you choose a microcontroller which has an inbuilt processor as well as an LCD controller. So on a single PCB and in a single IC, you have your main microcontroller and you also have the LCD controller. So that is one area where you save costs. The second area is, in many such applications, a backlight is not necessarily required. So there is enough ambient light when using that product. So as an example, when you're using a calculator, in a lot of cases you will see that there's no backlight at the back because you have enough ambient light. So that is also a huge cost saving. Now, customized displays have to be used only when there is a scale in production. So if you're looking at 100, 200 numbers, this display will not make sense. It will be very expensive and not feasible to make. So you need a minimum of 2K to make it worthwhile to go in for a customized display. Now, costing depends on a few factors. For now, we'll talk only of the glass panel. It depends on the size and it also depends on the number of segments. In fact, even the MOQ, which is the minimum order quantity, does depend on the size of display. So if it's a very small display, like a small thermometer display, your MOQ will be 5K or 10K. But if it's a larger display, like what you use for petrol pumps, then it can be as low as 1K. Finally, these displays, you can also have customization in the form of screen printing. Now, some of the displays that are coming on your screen, I have had to strike out or block out certain logos and certain names. This is in because of confidentiality reasons or privacy reasons. But if you look at this display, which is like a speedometer, so the numbers 0, 10, 20, they don't need to be displayed using a signal. So these are screen printed on the display. Or you also have colored screen printing. Again, I've had to block out a lot of the logos and symbols just in the interest of non-disclosure of data. But you do get an idea that in this drawing we have screen printing which is in color. Now, what are the characteristics while selecting a custom display and what we need to keep in mind, we will come to next. So now we're going to look at what a LCD looks like, or an LCM. So this is basically what a module looks like, either this or this. pretty much the same except that this has a blue panel, whereas this has a yellow-green panel. This has a yellow-green panel and this has a blue panel. So now what I'm going to do is, this is a standard 8x2 LCD. We're going to just open it up and look at its contents. So this is your PCB. This white thing here is your backlight. This is the glass panel or LCM, the actual display, and this is the bezel. So now one by one we'll go into each of the components. This PCB is basically the circuitry. Now the PCB can be of three types. This is COB, where is the chip on board. So the LCD controller or the chip is embedded inside this. The other two type of PCBs that are possible, one is SMD type. So here you have the IC directly soldered onto the PCB, or you also have a COG type, which is this. So here in this glass epoxy is where the IC and the rest of the components is embedded. So these are the types of PCBs. Now coming to the backlight. So this white thing is the backlight. I haven't removed it, but it's basically a separate component. Now this backlight can come in different colors. It can be yellow, green, it can be white. You can also have less standard backlights, that's blue, green, red. Now typically the standard backlights are yellow, green and white. Now if I just open this, you will notice that this is actually the diffuser. So this piece of paper or sticker is what diffuses the light which is coming from the back and makes the light sort of look even. This at the back are the LEDs. So this is the actual light source. Now this backlight can be of two types. One is array type, which is what this backlight is. So if you see, there is an array of LEDs. Typically this is used for yellow-green backlight. The other option is a white backlight, which looks like this. This white backlight, if you see, it has two LEDs over here, just either one or two LEDs, and this rest of the thing is the diffuser. So this actual acrylic, the actual acrylic part is the diffuser. So this typically the edge backlight is a white LED, because the white LEDs are more powerful than the yellow green, and this one LED over here can light up the entire glass panel. Now this metallic bezel is just for mechanical support. It is used to make sure that the LCD, that is the glass panel, fits tightly to the PCB and there is an electrical connectivity. If we don't have this glass panel, so if you see in this glass panel, the electrical connections come over here. The other type of glass panel is where you have pins. So if you see, this is a pin type glass panel, and here these pins can be soldered directly onto the PCB. Now this pin type is typically used for customized displays where we are not supplying the client with the PCB, and typically there is no backlight.